Okay, so good afternoon, everybody. So today I'm gonna continue talking about interrupts. Okay, so what I told you last time, guys, is um, we in this chapter I'm gonna teach two types of interrupts. Okay, one is called IRQ, the other one is called RTI. Okay, that's what I said. Okay, today I'm gonna give you more details. For example, let me tell you, just remind you what is IRQ. I told you we have a pin, okay, which is BE2 as far as I remember. So we have a pin, okay. Every time there is an event here on this pin, okay, we have a subroutine, you trigger interrupt. So every time event comes here, okay, you trigger interrupt. When you trigger interrupt, if the interrupt is enabled, you actually execute a subroutine. It's called IRQ, interrupt subroutine. So it is guaranteed, very simple. It's guaranteed. Every time there is event, you call the subroutine. Every time there is event, you call the subroutine. Every time there is event, you call the subroutine. Is that okay? So now, what do you mean by event? Okay, event can be falling edge. So every time there is a falling edge here, or it can be zero level. And this is something you can program, okay, as I explained last time. Okay, this is one question. Second question, where this event is coming from? It depends on your application. Maybe this event is coming from a sensor from somewhere. So we assume we have a device here. This device is going to give you trigger. It's going to give you, sorry, event of or falling edge when something happens. Like, for example, there is fire alarm or a train is coming, as I explained last time. And because there is event, I need to call a subroutine to do something related to this event. Okay. Now, uh, RTI is somehow different. RTI is a timer. It's different from IRQ. Okay, different. So number one, it does not have external pin like IRQ. It is something different. Okay, RTI is actually a timer. It's a timer, okay? Inside the microcontroller, it's not outside, inside the microcontroller, okay? This timer is used to make periodic interrupts, periodic. So for example, you can tell the timer, please timer, make interrupts every 131 milliseconds. So that means every 131 milliseconds, there is one interrupt, okay? So this timer is going to trigger interrupt every 131 millisecond. And again, what I mean when I say trigger interrupt, it means you execute a subroutine. Okay, so simply, very simple. I have a subroutine. Okay, if you set the time to 131 millisecond, that means I guarantee that this subroutine is going to be executed periodically every 131 millisecond. Okay, someone can ask me, okay, so tell me when in what case I should think about IRQ and what case I should think about RTI to use RTI. Okay, RTI usually it is used if you need like periodic interrupts. Okay, for example, I'm going to give you today the program. If you want to turn LED on for 1 minute, off for 1 minute, on for 1 minute, off for 1 minute. Okay, so if it is interrupted every 1 second or 1 minute, whatever it is, for example, if you make interrupt every 1 second, okay, that means I'm sure the subroutine is going to be executed every 1 second. And then I can write here flip LED. Very easy, right? So every 1 second, I'm going to call the subroutine. So subroutine is going to flip LED. Very simple, right? That means by this way, you can make a flashing LED every 1 second, okay? So if you need periodic interrupts, you have to use RTI. IRQ is different. IRQ, when there is event, this event doesn't need to be periodic, okay? Maybe I'm going to have falling edge, for example, and then maybe after 1 minute, I'm going to have another falling edge, and then after 1 day, so they are not periodic, okay? Anyway, so I'm going to give you, I'm going to talk about, I'll continue explaining the programming. Okay, guys. So what I explained last time, guys, I told you this is how can you program IRQ. Okay, as I told you, let me make the color red. So I told you in the main program, that's what you have to write in the main program. Okay. Number one, you have to write this one. You remember this one. I said all the time you have to use FF2. Okay, because this is the location where you have to store the restarting address of your interrupt subroutine, and this is the name. Okay, so always you have to do it all the time. You have to do it. Okay, this is number one. Number two, in the main program also you have to do two things. Number one, you have to enable all interrupts, and this is the easy part. You can just use CLI to enable all interrupts. Okay. Also, I told you there is a local enable bit, which is here in this register. Okay, interrupt control register. In this register, you can see we have a pin here. Okay, this pin is enable bit. Enable bit. Okay, that means if you put one here, you can enable IRQ interrupts. If you put zero, you disable IRQ interrupts. I'm gonna repeat again. What you mean by enable or disable? Very simple. If I put one, that means every time there is a falling edge, I'm gonna execute a subroutine because it is enabled. But if you put zero here and disable IRQ interrupts, that means if a falling edge comes, so we are not going to execute a subroutine because it is disabled. Okay. Anyway, so this number one. Number two, as I told you, it's up to you. Do you want to trigger interrupt when there is falling edge or zero level? It's up to you. So this is also something you can program. Where this pin here, pin number 7. Okay. So pin number 7 here, if you put one here, you want to make trigger interrupts every falling edge. If you put zero, you actually trigger interrupt at low level. Okay. Usually we are going to use two values here. One of two values, either C0 or 40, right? You are going to use C0 if you want to trigger at falling edge, because let me clear here, because this enable has to be one anyway. Okay. So what happens is that if you put one here, this is C0. Okay, if you put one here. And this one means, if you look here, this one means you want to trigger at falling edge. Is that okay? So you can use this one this way, okay? Or you can use number 40. Okay, if you use 40 means, let me delete this, you put zero here. When I put zero here, it means you want to trigger interrupt at low level. Is that okay? So you have to write this instruction here. Once listen to me, once I write this instruction here, so now the interrupt is ready. Okay, I programmed the interrupt. Okay, that means every time there is a falling edge, okay, so you're gonna execute a subroutine. Inside the interrupt subroutine, usually you have to do two things. Usually, okay, at the very end you have to write RTI. It's the last instruction. Return. This is the return. Okay. Remember, we had RTS, but this one is RTI. Difference between them, big difference. This is for subroutines. RTI, it is used for interrupt subroutines. Okay, but this one for any other subroutine inside the main program. Okay, so now you also need to write an instruction to clear the interrupt flag bit. You remember the interrupt flag bit? I told you before, it's just one bit. If a device want to trigger interrupt, has to put one here. And when you serve the interrupt, that means you execute the subroutine, you have to write an instruction here to clear it. Otherwise, if you don't clear it, you are going to create continuous interrupt. Okay, because makes sense, right? I have to put zero because I served the interrupt, so that means it is done. Okay, but so always we have to do that, except only in one case, one exception. This case is in IRQ. In IRQ, you don't need to clear this interrupt flag bit because it is done automatically. This is the only exception. Right now, just a few minutes, or just very shortly, I'm going to teach RTI. You will see in RTI, I have to write an instruction to clear it. Okay. Now, let me see you. In chapter 3, I taught a program. Do you remember the program I taught? Every time you press one button, you shift the LED. So I taught this program in chapter 3. So you remember this LED was on when I press a button. So actually, next one is going to become on. When I press a button, next one is going to be on. Okay, until the end, and then after the end, you have to bring it back here. So every time you press a button, you actually it's going to shift the LED. Okay, so the one that's on, you shift it. Okay, so that's what we did in chapter chapter 3, but the difference is in chapter 3 we did it in the main program. Okay, now I want to move this task to IRQ, as I told you before, and this is very important thing to learn, guys. Very important thing. Okay, now my program is completely different from what we did in chapter 3. Okay, in chapter 3 we had a main program. It has subroutines, everything. Okay, and now you may have a bunch of subroutines, right? Like for example, RTI, IRQ, timer, whatever. Okay, usually the way you are going to do it is we are going to write a task here. So you are going to put one task in the main program, and then you can put one task here, and you can put one task here, and you can put one task here. Okay, and what happens, your program or microprocessor should move quickly from here to here, here to here, quickly, here to here, quickly. Okay, so that by this way we can run multiple tasks. Okay, so someone can ask me, what do you mean by task? I'm going to tell you what I mean by task. For example, okay, very quick example. If I want to use like last lab, I want to use LCD, okay, and 7 segment. Okay, I can write it here. So LCD, LCD and keypad. That's what we did. So I can, if this is like a one task, I can put it here in the main program. Okay. So this is one thing. Another thing, I want to use 7 segments. So I need time multiplexing. As I explained before. I can put here time multiplexing. Is that okay, guys? Also, when I press a button, I'm gonna put it here, time multiplexing, because it needs periodic action. That's what I'm gonna teach in this chapter as well. How can you do? I'm gonna repeat most of, or not most, but I want to repeat some. I'm gonna repeat some programs I did in chapter 3. But what I'm gonna do, I'm gonna move these programs from the main to subroutine. Okay, to interrupt subroutine. Okay, so I can put here time multiplexing so that the LED can work. Okay, then I can use IRQ to count events. Okay, for example, that's what I'm going to teach right now, to count some events. Okay, what do you mean by count events? What I mean by count events is, for example, you can have like infrared. So this is like a light, infrared light. Okay, and then when someone, I can put this infrared at the front door of, for example, Walmart or any shopping center, any shop. Okay, so that when one person cut, or when one person cut this light, you actually is gonna create, event this way. Okay, so you are gonna, and then you are gonna trigger IRQ, and then IRQ can count how many people enter the store today. For example, I'm just giving you example. Okay, so by this way, I can have what I'm explaining is I'm gonna have multiple tasks. Is that okay? So IRQ is gonna take care of counting how many people enter the store. Every time one cut this infrared, IRQ is gonna increment the counter. This is number one. Number two, RTI can be used for time multiplexing. So this is the second task. Okay. Number three, I can put something like LCD keypad in the main. Okay, and so on. Okay, so by this way, this is the beauty, this is the importance of interrupts. Okay, because of interrupts, we can program big programs. You can make multitasks. Okay, what we did in chapter 3, we ran only one task. Okay, because we only used the main program. Okay, only one task. Now we're gonna have more than one task. So what I programmed in chapter 3, you can put these programs in RTI, one task in RTI, one task in main program, and so on. Okay, so now let me come to this program. So what I want to do here, guys, in this program is, what I want to do in this program, guys, is, okay, you remember PH0. Okay, you remember when we used the push button? So every time I press the push button, actually, I'm gonna create a signal like this one. So here I press a button, here I press a button, and so on. That's what we did in chapter 3. Every time I press a button, I'm gonna generate a signal like this one. Okay, so if I connect PH0 to BE2 using the external wire between BH0 and BE2, that means every time I press a button, actually you are going to trigger one interrupt. Why? Because there is falling edge here, there is falling edge here. So every time I press a button, I'm gonna trigger one interrupt. And that's what we're gonna do in the coming lab, by the way. Okay, so let me go back, just explain what do you mean by external wire. It's not clear. Okay, oh, it's not here. Okay, I think, yeah, here. No, it's in chapter, I'm sorry. The picture, okay, so I have to go to chapter 3. The picture is in chapter 3. Here, guys, that's what I'm saying. One second. That's what I'm saying, guys. BE2 is here. BE2, this is this pin. Okay, so you can connect a wire, for example, here between BE2. I'm not sure is it BE2 or BE1. I will check. So, but anyway, I'm gonna. I just don't remember. I will tell you. I think it's BE1. BE1. I will check right now. But anyway, BE1 is here. BE2 is here. Anyway, so for example, if IRQ is triggered from BE1, okay, then you connect external wire this way. Okay, between, for example, you can use BH0, you can use BH1, BH2, or BH3. You can use any one of these. You remember? Okay, so if you use BH0, you have to connect wire this way. If you external wire between here and here, is that okay, guys? By doing that, every time you press a button, you actually, here on this pin, you are going to generate a signal like this one. And because of this wire, this signal is going to come to IRQ to make interrupts every falling edge. Okay, so here in the board, yeah, here in the board, you can find BE1 is here. It's here, BE1. And also you can find BH this here. Okay. Anyway, okay, guys. So you can find here BE1 and BE2 are here, and you can find BH are here. Okay. Again, you can use BH0, BH1, BH2, or BH3 because we have 4 push buttons. You can use any one of these push buttons. Okay. And then also you can, all what you have to do, you have to connect the external pin of IRQ, external wire this way, so that when you generate a signal, when you press a button, you actually trigger interrupt. Okay, I'm going to tell you now if it is BE1 or BE2. I don't remember.
I have a question.
Yeah, sure. But
so which pins
let me answer this question first.
I
told you guys it's BE1, as you see here. Okay, so it is not BE2, it's BE1. Okay, just give me 1 second before I take your question. Yeah, here. Yeah, here, guys, look here. So IRQ is actually BE1. It's connected to B1. Yes. Yeah. Now, what's your question?
So every time that I want to use the IRQ interrupt, I have to hardwire the ports that I want to use to port E1?
That's a very good question. Okay. The answer is no. No. Okay. It depends where. So the answer is every time you use IRQ, you need event, right? You need falling edge. Okay. You need event. Okay. So if this event is coming from a sensor, you don't need to wire to BH. You understand what I'm saying? Okay. The reason I want to BH only in this program, because in this program, what I want to do is every time you push a button, I want to trigger IRQ interrupt. I want to do something. Every time I press a button, I want to do something. You got what I'm saying? And this thing, what I want to do here, I'm going to put it in IRQ. So when I press a button, I'm going to trigger IRQ interrupt, and then I'm going to write here shift LED. That's what I want to do here. You got what I'm saying? So it depends on where the signal is coming from. You got what I'm saying? So it's not always you have to wire it. No, the answer is no. Only in this program. Is that okay?
Yeah.
Okay. So now let's see. I'm gonna explain this program, guys. What I said in this program, I have a push button what I'm gonna do every time I hit the push button, I'm gonna shift the LED. Okay. So number one, here I decided to use IRQ as I told you, and then I'm gonna connect, as I said, PH0 for example. I'm gonna connect it to IE1. Okay. Sorry, not TE1. Port TE1. Okay. And then so that every time I press a button, you are gonna actually create falling edge, and then this falling edge is gonna trigger interrupt. Okay. So this interrupt is not gonna work, this IRQ interrupt, until you configure it. Okay. This is what I'm saying here. That's what I taught. So you have, number one, you have to write this org, guys, and very important. Okay, where I have to write this org, should I put it inside the program? False, you shouldn't. So now my program should look like something like that, org 1000, as usually we do, and then you put your data here, and then we have here org 4000, and then you put here code, any code here, including subroutines. Okay. Also you can put here also after the subroutine here, you can put interrupt subroutines here as well, interrupt subroutine. Okay. But for sure your code shouldn't come all the way this way. Okay. So this is like main program. Here in the main program, you have to come this way, and then you have to come back to here. So this should be somehow separate. Okay. But still you can write interrupt subroutines here after the main program. Okay. Now where I have to put this one, I have to put this one here. Okay. So the org here. Okay. I know this small thing makes mistakes to students. So what I'm saying, this org, it's not, you should not put it in the code part. Okay. Section. Okay. Anyway, let's see what I did here, guys. So this is the main program here, as you see. What I did here is just to configuration. So here I configure port B because I'm using LEDs. Here also I configure port H because I'm using push button. Also, as I said many times, you have to enable LEDs. You have to disable 7 segment. So all this part just related to the push button and LED. That's it. Okay. Even this part here, I'm gonna turn one LED on. Okay. Now I need to configure the IRQ. So this is number one here. I have to write this one here. Okay, this number one. Number two, I have to write these two instructions as I have just explained them. This CLI to enable interrupts. This one, as I explained, this one is gonna do two things. This one is gonna enable IRQ interrupts, guys, and also you are gonna respond to falling edge. Okay, so once you come here, okay, so I'm gonna keep looping here, as you see here. Someone can ask me, okay, but let me clear the screen first. Okay, someone can ask me. So this is the main. That's what we call, guys, main program. Main. Okay. In the main program, you have to do configuration. You have to do configuration in the main program. Also, you can put one task. If you have a task, you can put one task here. Is that okay in the main program? Okay. But here, because I'm just teaching a simple program, I have only one task. One task. This task, I'm gonna put it in IRQ, not in the main program. Is that okay? That's why you can see here, I'm just creating a loop here. Okay. Because once the program come here, the program is gonna stop here. Okay. And then if there is interrupt, you are gonna go execute interrupt and then come back to here. Go execute interrupt and come back to here. Is that okay, guys? Again, what I'm saying is this is a simple program. This program has one task. I'm gonna put this task in IRQ. Is that okay? In most of the time, in bigger programs, you are gonna have multiple tasks. So in this case, I'm not gonna use this one. I'm not gonna use this branch. Instead, I'm gonna write a code here. I'm gonna write a big program here like LCD, 7 segment, whatever. Is that okay? So, and same thing, you're gonna leave here, execute subroutine, and come back. Okay, guys? Any question? So let me tell you the conclusion. The conclusion is, guys, and this is a good thing, very good thing. I'm gonna tell you what this is. Okay. The conclusion is every time you wanna use IRQ, this is how can you program it. Number one, number two. Once you do this, you already set up the hardware so that every time there is a falling edge on IRQ, you execute a subroutine. It's gonna work. Okay, guys. The good thing is, usually this configuration is fixed. Usually we don't. This one for sure we are not gonna change this one. Okay, for sure. Okay, we are not gonna change this one for sure. The only one that you may need to change this one. Okay, you may, because remember this one has 2 bits. One bit here, I used this bit here to program it for falling edge. Okay, you may need to make, you may need to use here 40 if you wanna trigger interrupt at low level. That's it. So conclusion, once you write this instruction here, guys, number 1, and this is number 2, now IRQ is working, which means every time there is a falling external falling edge on the external pin, you execute a subroutine. Okay, now this is a good thing, guys. So every time you use IRQ, very easy, just you have to put it here. Now what you want to do every time there is a falling edge, what do you want to do? Okay, in this specific program, what I want to do, I want to shift LED. Okay, write the code, this code in IRQ. Okay, that's what I did here. If you look here at IRQ, guys, this is a subroutine, IRQ subroutine, guys, as you see here. Okay, number 1, the first part here is just deep bouncing code, because maybe there are some bouncing. You remember what I did before? If there is a bouncing, if I don't write this code, what's going to happen is that you can make interrupt here, you can make another interrupt here. Every time there is a falling edge, you make interrupt. Okay, that's why I use deep bouncing code here, so that every interrupt I want to shift the LED only one time. Okay, anyway, this is similar to what we did before. Okay, and here in this interrupt, you can work in you can work in PTE, okay, PTE1, or you can work on BH0, any one of them, because they are the same. You connect a wire, so any one of them should be okay. Okay, so this part is just for deep bouncing. And now you are gonna shift port B. And now if port B is not 0, I'm done. I'm gonna come to here so that I return it back. Okay. Otherwise, if port B is 0, as I explained it before, that means you shift the LED all the way, and now I have to return back to here. And that's what I did here. Sorry, this is shift left. So it's here what I'm explaining, shift right. It's not a big deal. Okay, so here I'm gonna start from here, and then I'm gonna shift this way. Once port B is 0, port B is 0, so I have to return back here, as you see here. Any question, guys? So the conclusion is, guys, every time there is falling edge on the external pin, this code is going to be executed. Okay. Okay. I'm going to tell you something now interesting. Okay. I can use IRQ for different purposes for different programs. Okay. Usually, you are not all what you have to change is just what you are going to write here. That's all what you have to change. Okay. For example, I give you here an example. If I wanna every time I press a button, okay, I wanna turn LED on. If it is on, I flip LED. So here, if it is on, I'm gonna make it off. If it is off, I'm gonna make it on. All what I have to do, guys, just remove this code, put this code here. If I do that, IRQ is gonna do this task. Instead of shifting LED, IRQ every time I press a button is gonna flip LED. That's it. Okay. There is another thing. What if, as I told you, what if these falling edges are coming from like, as I told you, infrared? You are counting how many people entering a store, for example. So you put like an infrared. Every time someone cuts a line, you actually is gonna generate. You are gonna generate a falling edge. Okay. So now I want to count how many people entered the store. Okay. That means every time this subroutine is called, that means someone entered the store. Is that okay? You understand what I'm saying? This is how it is. When someone enters the store, okay, he or she should cut the line, should cut the infrared light, okay? And then when you cut the infrared light, you actually is gonna trigger interrupt. That means every time IRQ interrupts, that means someone enters the store, okay? And now all what you can do, that's what I'm saying. So you can just put this code here if you want. You can put this code. Okay, guys, any questions? Very easy. It's very easy. All what you have to do, just you have to write this one every time. We have to write this one for configuration. Once you do that, you have a subroutine. Okay, every time there is a falling edge, this subroutine is called, and then you what you want to do, just put it here in this subroutine. Any question, guys? Okay, I want to tell you something, guys. You can use also IRQ for frequency meter. Frequency meter. We did it in the past. So the idea is that if I connect IRQ, so we have square wave this way. Okay, guys. I'm gonna connect this one to IRQ. Look at the idea. Okay, I'm gonna connect it to IRQ. Okay, I'm gonna enable. So here I'm gonna enable IRQ, and then I'm gonna wait 1 minute. Sorry, 1 second, and then I'm gonna disable IRQ. Okay, so I'm gonna enable IRQ only for 1 second. Okay, why? Because I want to count how many falling edge we have. So this is one falling edge, one falling edge, one falling edge, one falling edge, and every falling edge every one falling edge means one cycle. You got what I'm saying? And then my count is a frequency. My count is a frequency. Okay. So what is the definition of frequency? Is a number of cycles in 1 second, right? So the way I can use IRQ to measure frequency is I can take the signal, I can input it to IRQ, and then by this way, I am sure IRQ is interrupted every 1 cycle, 1 interval, 1 cycle. Is that okay? And then all what I have to do, I need to count how many times IRQ is interrupted in 1 second. And this gives you the frequency. Okay, any questions? Any question? Okay, guys. So now what I'm gonna do, I'm gonna explain the same thing I did right now, but it's gonna be in C language. So I'm gonna teach how can you program IRQ in C language, which is very easy. You'll see right now. Number one, you have to use this one, IRQ underscore enable. So IRQ underscore enable, this one is gonna enable IRQ for low level. Okay. So if you wanna program it for falling edge, you can use this one directly. Okay. Interrupt control equal C0, or this one is programmed for 4.0. Another way is I already taught before how can you go inside this function so you can see what is inside this function. You will see if you go to inside this function, you will see this one here, this instruction here. Okay, so all what you can do, you can change but it's going to be 40. You can change it to C0 if you want. Okay, so if you want to use IRQ in C language, this is the first thing you have to do. Okay, and this is the main program. This is my main program. My main program is here. Okay, and now this is the interrupt subroutine. This is the interrupt subroutine. Okay, so the interrupt subroutine here, this is the way you have to do it, guys. Number one, it has to start with the word void. This is a keyword, you have to use it. Also, you should write here the word interrupt. It's a keyword, you have to use it. Is that okay, guys? Also, here you have to use number 6 for IRQ. Okay, every interrupt source has a different number. Is that okay? And then you can write the name. Here it can be any name. Okay, but usually the name should tell the people this is IRQ interrupt. But actually you can put here any name. Is that okay? So this is how can you program any interrupt subroutine in C language. Any one. Okay. The only difference is that here you have to use this one. You have to use this one. Okay. This number, every interrupt source has a different number. So for IRQ, you have to use 6 all the time. Yes. And then here you can just use any name. Okay. So tell me how you come up with this number 6 here. How, for example, if for any other interrupt source, how I can get the number? Very easy. If you look at the table here, this interrupt source is number 0. This is number 1, number 2, number 3, number 4, number 5, and this one is number 6. So when you want to use IRQ, you have to use number 6 here. Okay. If I want to use RTI, so you have to use number 7. Is that okay? Number 8, and so on. Any question, guys? So this number can tell the C language which interrupt source is that. Okay. So here we are going to use number 6. Okay. Now let's see how the program works, guys. So here, so if you look here, let's first look at the main program. In the main program here, that's what we do all the time. 7 segment disable, LED enable, direction register H, port B. This is just you configure port H and port B. That's it. Okay. And then here you have infinite loop. So once you come here, you are gonna have infinite loop here. This is similar to this branch, the branch here, this one. So here you have infinite loop, and every time there is a falling edge, you actually go execute the subroutine and come back. Go execute the subroutine and come back. Is that okay? Then, so here, so now let's look here at the subroutine, guys. Okay, similar to what I did before, guys. So here I guarantee, I am sure every time there is a falling edge, this subroutine is going to be called. I am sure. So what you want to do when there is a falling edge, what you want to do, okay? This is similar to what I did before. This is for debouncing. This part is for debouncing. And then I'm going to shift to port B, okay? And then if port B equals 0, I'm going to make it 1. So this is exactly similar to what I did before. Any question, guys? So conclusion, before I allow you to ask questions, if you have any questions, so conclusion. Number 1, okay? In order to configure IRQ in C language, okay, you can use this one. You have to use this one here, but keep in mind this one is used, okay, for low level. If you want to program it, falling edge, so you have to write this one. You have to use this one, okay. Sometimes I can tell you, sometimes this one didn't work with us for some reason. Sometimes it works, sometimes in some ports it didn't work, okay. So if it doesn't work, all what you have to do, guys, you have to go inside this function. You will find, when you go inside this function, you will find here, you will find this instruction here, but this one is going to be 40. All what you have to do, you have to remove it and make it C0. That's it, okay. But it worked with us with some ports, okay. This is number 1. Number 2, you have to, this is interrupt subroutine. You have to use number 6, okay. You have to use different name for each interrupt subroutine, okay. And then you write whatever you want to write here, okay. It depends on what you want to do. Every time what I can guarantee for you, every time there is a falling edge, this subroutine is going to be executed, and then it depends on you what you want to do in your program. In this case, in this program, I want to shift LED. That's why I'm shifting LED. Okay. Any question, guys? Okay. Now I'm going to move to RTI. And the good thing is, that's what I said before, guys. The good thing is, there are 2 very good things here, guys. Number 1, if you learn how can you program one interrupt, it's easy to program others because all of them almost the same way. This is number 1. Number 2, if you learn how to program IRQ, all the time I'm going to use the same code because it's like a configuration. All what you are going to change, what I'm going to change, what should I write here inside the subroutine? Okay. For example, if you want to do shifting LED, you have to write this instruction for shifting LED. If you want to count events, you have to write the code here. So that's usually the only part you change from one program to another. That means for all the program, we're going to use the same configuration, unless you wanna do some change here. Okay. Anyway, now I'm gonna come to RTI. I told you guys, RTI is a timer. It is used. It's different from IRQ because IRQ has external pin. Every time there is a falling edge, you want to execute a subroutine. RTI is different. RTI is used if you wanna make periodic interrupts every fixed time. Okay, as an example, if I want to make a flashing LED like what I did in chapter 3, okay, so here I can make periodic interrupts every 1 second, okay, and then here I can flip the LED. If it is on, you make it off, okay, and that's what you have to write. So that's what you have to write in the subroutine, in RTI subroutine, okay. because when I say I'm gonna trigger interrupts every 1 second, what I mean is the subroutine, the RTI subroutine, you are gonna execute it every 1 second, right? Because this is how interrupts work. When you trigger interrupt, you execute the subroutine. So here that means I have a subroutine, I have a code, and I am sure this code, I'm gonna run this code every fixed time. For example, every 1 second. Okay. By this way, I can make like a flashing LED. Is that okay, guys? Another thing, that's what we're gonna see right now. So don't worry. Another thing, you remember the idea time multiplexing of the 7 segment. So for example, if I want to display 7, 3, 2, 1, for example, I told you I'm gonna make 7 and everyone is off, right? And then I'm gonna make 3, everyone is off. Remember the time multiplexing, 2, everyone else is off. 1, everyone is off. And then I'm gonna repeat again. Okay, so that's what I said. Here, I taught it in chapter 3. How can you do something like that? But in the main program. Okay. Now I'm gonna teach how I can move this task and put it in RTI. So RTI can do this flashing so that the main program, it can be free to use it in something else. You got what I'm saying? So everything actually I teach in chapter 3. You can move, you can here move it. I taught in chapter 3 how can we do these programs in the main program. Okay, and you can easily move these tasks to the interrupt subroutines. Okay, so RTI here can take care of this one. So in the first interrupt, I'm gonna do this. Second interrupt, I'm gonna do this. Third interrupt here. Fourth interrupt here. Fifth interrupt, I'm gonna come here. So every interrupt, that's why it's periodic. That's what I'm saying. It's easy, it's not difficult. You can ask yourself when I have to use IRQ and when I have to use RTI. Very simple. RTI is used if you need periodic interrupts, like this case here. In this case, I need periodic interrupts. Anyway, so I'm gonna teach. So here I make a definition. What is RTI? Also, I explain when or how can you use RTI. Now I'm gonna teach programming. How can you program RTI? Okay. You will see it's very close to what I did before. Number one, this one here. Okay, this is similar to what I did in IRQ, guys. The only difference is you have to use a different number here because as I told you last time, every interrupt source has a different location, and then also you have to use a different name here. Right in IRQ, I used the name IRQ something here, but this number is fixed. You have to use this number for RTI. Here, let me go back just to remind you. Here it was FF. Here it was FF2, right? Here it has to be FF0. Remember, I taught it before. I told you how can you come up with this number? It's here. It's here. This number is here. So this is FF0 for RTI, FFE, for IRQ, it's FF2. Okay. So this is the location where you have to put the starting address of your subroutine. Okay. So this is number one. Any question here? That's easy, right? Number two. Configuration. I told you we need to do configuration. And what I mean by configuration here, how can you set the timeout? How can you set the timeout? Okay. What I mean by timeout, this is the time between interrupts. So if the timeout is for example is 131 milliseconds, that means I'm gonna generate interrupts every 131 millisecond. Okay, this is the timeout. Okay. So how I can program the timeout? Okay, very easy. We have a register. This is the name of the register, RTI-CTL. RTI-CTL. Is that okay? In this register is used to set the timeout. RTI-CTL. How this one is used to set the timeout? I'm gonna tell you how. We have two values. One is called N. The other one is called M. N is the first four bits in this register. So the first 4 bits here, guys, in this register, these 4 bits, I'm gonna call it N, and it can take a value from 0 to 15. Is that okay? The second, and then the 3 bits here, that we call it M, and it can take a value from 0 to 7. Is that okay? So depending on what value you put here, you can determine what time. Okay. So what is the relation? This is the relation. It has like a mathematical equation, as you see here. This is the mathematical equation. This is the value of N. This is the value of M. Okay, and in microsecond. Okay, so based on what value you put for n, what value you put for m, you can make a timeout in microsecond. Here in this table, I put all the values here in this table, guys. So for example, here this is m. M takes a value from 0, 0, 0 until 1, 1, 1, 1, as you see here. Okay, m, this is m, n is here, this is n is here. It takes a value from 4 zeros to 4 ones, as you see here. Okay, and then what I'm calculating here, what I put here in this table is actually here, the numerator. Okay, it's here, this part. So that means any value here in this table, you have to divide it by 8 microseconds, as I said here. Let me go back here. So here you have to divide it by 8. For example, if you look here, this is the smallest value. Okay. If you divide it by 8 microseconds, that means the smallest, the shortest time out is this one, 0.128 milliseconds. That means this is the shortest. It cannot, using RTI, I cannot make it shorter. Okay, that means you can trigger interrupts every this 0.128 millisecond. Okay, if I take some value here in the middle, like this one, for example. Okay, so by this one here, you can actually trigger interrupts every 10.24 millisecond. Okay, if I take the maximum time, this is the maximum value. Maximum value here, guys, when it is 1111, 1111, you can see here 111, 111. Okay, so if you take the maximum value, this is the maximum delay, 131 millisecond. This is the maximum delay. And this one is the minimum delay, and this some value in the middle. Okay, any question, guys? Most of the time, we're not gonna. I know it's little bit. The problem here in this timer, it's not very flexible. Okay, flexible when you select the time out, because you just have a bunch of delays, and you have to select one of these delays. There is no much flexibility. Okay, but in chapter 5, okay, there is another timer system which is more sophisticated than this timer. Okay, you have more control in the time out. You can increase the time out little bit. But here you have just a bunch of time out. You can just, but still it is useful in some application for sure. Okay, so most of the time here, guys, we are gonna use here this one. Let me. Most of the time, guys, if we can use this value, okay, or we are gonna use this value, or we are gonna use this value. One of the 3 values. Okay, so if you use this value. So what number I have to put here, guys? The number I have to put here, this is n, right, which is 1111, and this is m, which is 1110, which means 7f. So 7f means this value. Is that okay? What about this one? If you use this one, what number you have to use? The number I have to use, guys, here, 1001, and then I have to use this one, which is 001. Okay. Let me know 124. I think this is 4. 124, and what this value is 1248 49. Same thing here, guys. Here it's going to be 0000, this part here, and it's going to be 100, which means it's 10. So all the time, guys, so let me tell you the conclusion. Number 1, if you want to make the time out 131 millisecond, all what you have to do, you have to write 7F in this register, RTI CTL, this register. Okay, this is number 1. Number 2, if you need the time out to be 10.24 millisecond, the number 49, put 49 in this register. And if you need very small time like this one, so you have to put 10, number 10. And it's the same way you can use any other number, but most of the time we're going to use one of these numbers. Any questions? Okay, so that's what I did here, guys. That's exactly what I'm saying. So now, in order to program the time out so that I'm gonna get 131 millisecond, I'm gonna move 7F to RTI CTL. Is that okay? Okay. Number 2, our next step you have to do in the programming. You remember I told you guys, every register, every interrupt source should have 1 bit. We call it enable bit. This enable bit, if you put 1, you enable interrupts. You put 0, you disable interrupts to turn the interrupt source on and off. So here for RTI, where is the enable bit? Okay, the enable bit is here in this register, this one. Okay, CRGINT, this one. Okay, so all what you have to do, guys, very simple, very simple. If you want to enable RTI interrupts, you put 1 here. Okay, if you want to disable, just put 0 here. So that's why we're gonna use this instruction, bit set. Okay, so this is to enable RIT interrupts. If I make it bit clear, you disable. So bit set enable, because you are gonna put 1, bit set you are gonna disable. Is that okay, guys? So someone can ask me, what do you mean by enable or disable here? Okay, I mean if you enable, you are gonna have periodic interrupts. So the functionality you have is gonna work. You have a certain functionality. For example, this periodic interrupts is going to be used, for example, to flash LED, to do something functionality. For example, you are going to flash LED. Okay, that means if you enable interrupt, actually you are gonna trigger periodic interrupts, which means you are going to have flashing LED. You can see the LEDs flashing. But if you disable RTI interrupt, that means you are not going to trigger interrupts. That means I'm not going to execute the subroutine of RTI. That means there is no flashing. Is that okay, guys? So anyway, so what I'm saying here, we have only 1 pin, enable bit. It's here, this bit. Okay, you can use this instruction to enable or disable. By the way, same thing here in IRQ. You also, that's what I explained. Here, this bit here, which is this bit. Also, it can be used to enable. I'm sorry, I think next one, this one. Yeah, this one here, this bit here. Okay, it can be used also to enable or disable interrupts. Again, guys, I want you to understand what I mean by enable or disable interrupts. Okay, in case of IRQ, if it is enabled, every time there is a falling edge, you execute a subroutine. If it is disabled, if there is a falling edge, you are not gonna, anyway, you are not gonna execute the subroutine at all because it's disabled. Okay. So now, the last thing I want to teach here is before in the configuration is also, I told you every interrupt source should have a flag bit, what we call a interrupt flag bit. Okay, interrupt flag bit, and I told you the interrupt source is gonna put 1, and you in the interrupt subroutine you have to write an instruction to put 0 to clear it because I served it. So your request, when I serve you, I'm gonna put 0 here. That's how it works, all right? And I told you in any interrupt source you have to write an instruction to do that. And I warned you, if you forget to do that, your program is not gonna work because you are gonna have like continuous interrupts from this source. Okay, because this one is gonna be 1 all the time. When this one is 1, you trigger interrupt, so it's gonna be continuous interrupt. Okay. I told you the only exception is IRQ. IRQ you don't need to write an instruction because it's done automatically. So now tell me, where is this bit? Where is this bit? This bit here in a register in RTI, it is a register called here, this one, CRG flag. Okay, this bit here. Okay, so very simple. When RTI wants to trigger interrupt, it's gonna put 1 here. Okay, in the once you serve the interrupt in the interrupt subroutine, you have to write 0 here. Okay, how? This instruction. That means always in RTI subroutine, I have to write this instruction. Always in RTI subroutine, I have to write this instruction. I have to clear this bit. I have to clear this bit. But anyway, the way you will clear it, you have to clear it by writing 1. This is how it is designed. So you clear it by writing 1. This is how they made it. Okay. So all the time you have to write this instruction. So let me tell you before I choose a program. This is a conclusion, guys. Here. How can you program RTI? Number 1. Okay. Number 2, you need set up the time. You need to set the time here, RTI CTL. You have to know what is your delay, how much is your delay. Usually you are going to use one of three values, either 7F, 49 for this delay here, for this one, or here number 10, okay? And all what you have to do, you have to move this number to here to set the time. This is number 2. Number 3, you have to use this instruction to enable interrupt. If you want to disable interrupt, and that's what you need to do in the coming lab, I guess. You need, if you need to disable interrupt, you have to use bit clear instead of bit set, okay? This is number 3. Number 4, in the interrupt subroutine, always you have to write this instruction, okay, to clear the flag bit. Okay. Any question before I choose the program? Any question, guys? Okay. Let me tell you in this program what we want to do here in this program. I want to do flashing LED, similar to the first program I taught in chapter 3. But the difference is in chapter 3, I did the flashing LED in the main program. Now I want to move this task to the RTI. So RTI subroutine is going to take care of it. Okay. So how I can do it? Okay. Very simple. All what you have to do, guys. All what I need is, listen to me. All what I need is, I need interrupt here, and then interrupt, another interrupt every 1 second, and then another interrupt every 1 second. Is that okay? And then here I'm gonna say flip LED. You know what I mean by flip LED, okay? If it is on, I'm gonna make it off. If it is off, I'm gonna make it on. Okay, flip LED. That's it. So I have to write this one in the RTI subroutine. So now I have RTI subroutine. This RTI subroutine can be called every 1 second. You are gonna call it every 1 second. Is that okay? And what I'm gonna write here in the interrupt subroutine, flip the LED. Okay. So for example, this is the interrupt subroutine. I am sure this subroutine is gonna be called every 1 second. So here I'm gonna toggle, as you see here, guys. Just toggle. So every 1 second I'm gonna toggle the LED. By this way, I can make flashing on for 1 second, off for 1 second, on for 1 second, off for 1 second. But this is done by RTI, not in the main program as we did before. Any questions? Any questions? Okay, but we have a little problem. What is the little problem we have? The problem we have is here I want to make interrupt every 1 second. But RTI, so from here to here, 1 second. RTI does not allow me to have this 1 second time out, because if you come back to here, what is the maximum value here I can get for time out? 131 millisecond, as you see here. It cannot be 1 second is too long time. The maximum time is 131 millisecond. Okay, guys. So what should I do? I cannot change the hardware. This is how RTI is. The maximum RTI can give me is every 131 millisecond. Okay, guys. So the way I'm gonna do it here is, okay. So here I'm gonna count. This is interrupt 1 after. This is after 131 millisecond. This one is another 131, another 131. Okay. So here in the first interrupt, I'm not gonna do anything because it's just 131 millisecond based. I'm gonna flip. I wanna toggle the LED every 1 second. So that means guys. So that means I have to toggle the LED every 8 interrupts. 8 interrupts, because 8 interrupts means 1 second. You got what I'm saying? 8 times 131, it's almost means 1 second. This is millisecond. Okay, guys. So this is exactly how it works. So when RTI is interrupted, this is, I'm gonna count. Interrupt 1, do nothing, leave the interrupt subroutine. Interrupt 2, do nothing, leave the subroutine. Interrupt 1, 2, 3, 4 until interrupt 8. So I'm gonna take action every 8 interrupts, because 8 interrupts, it means 1 second. Okay. I think you need this part in the coming lab. Okay. In the coming lab, I'm gonna tell you make flashing every 1 second. Okay. And then I tell you make flashing every half a second. So how can you do it? Very easy. Half a second means 4 interrupts. So I have to toggle every 4 interrupts. If I tell you make flashing every 2 seconds, that means I have to toggle every 16 interrupts. You got what I'm saying? So I'm gonna show how I do it here, guys. But this is the main idea. Oops. Let me. Number one, let's come here to the programming as I usually do. For sure, you have to raise this part here, guys. Okay. Here, number 2, you have to raise this one. I'm gonna set the time. I'm gonna put here 7F so that I'm gonna get interrupts every 131 millisecond. Okay. And then here, this is what I have just told you. I have to enable RTI interrupts and then a clear interrupt. And then because here I am making a simple program. I have only one task. I'm gonna put it in RTI. Is a main program is free. Okay, so that's why if you see here, guys, I'm gonna make infinite loop here. Again, in reality or in big programs, I'm gonna put one task here because as I told you, now your program should have several tasks and then you can decide, I'm gonna put this task in the main program. I'm gonna put this task in IRQ. I'm gonna put this task in RTI. I'm gonna put this task in timer or in serial communication. I told you we have different sources of interrupts. Is that okay? So here, because I don't have task here in the main program, just a very simple program. So here I'm gonna keep looping here, and every 131 millisecond, I'm gonna go execute a subroutine and come back. Every 131 millisecond, go execute the RTI subroutine and come back, and so on. Is that okay, guys? Okay. Now let's see. This is the subroutine. As I told you, always you have to write this one in the beginning of the subroutine in order to clear the flag bit. Okay, and this is my program is here. Look here what I did here, guys. Increment a counter. So I have a counter here. Every interrupt, I'm gonna increment a counter, and then I'm gonna compare the counter to 8. And if it is not 8, I'm done. Come to here, just leave. So you can see here, guys. When I come here to the subroutine, here I'm gonna come to here, and then if it is less than 8, okay, that means it is not 1 second yet. So I'm gonna come to here and leave. Is that okay? Once, if it is not equal, once it is equal, I'm gonna come here. So here I'm gonna come here. Every 8 interrupts, I'm gonna come to here. What should I do? Number 1, I have to clear the counter. I have to clear the counter to count for another 8. Okay. So here this counter should start with 0. And then every 8, I'm gonna make it 0 again. Every 8, I'm gonna make it 0. Okay. And then I'm gonna flip. By this way, every 8 interrupts, I'm gonna execute this part. So this part here, guys, should be executed every 8 interrupts. Okay. Very simple. That's what the coming lab is, the easiest lab. Okay. In the coming lab, guys, because I know it is by the end of the semester, you don't have much time, but it's very easy lab. Okay. What I'm saying is that if I want to modify this program to flash the LED every 2 seconds, very easy. I'm gonna make this one 16. That means I'm gonna execute this part every 16 interrupts, and 16 interrupts means 2 seconds because you are gonna multiply 16 times 131 milliseconds. It means 2 seconds. Is that okay? Same thing, guys. If you wanna make interrupt every half a second, half. So all what you have to do, guys, this one has to be 4. Just make it 4. Is that okay? Any question? Okay. Okay, here I'm giving you a warning here, guys, a warning. Now, I need to count this interrupt 1, interrupt 2, interrupt 3, interrupt 4, okay? In order to count, you have to use a memory variable. You have to use a memory variable, okay? You should not use a register because registers don't memorize their values, okay? Why? Do you remember what I said before? Because in interrupts, automatically all the registers values are pushed in the beginning. RTI is gonna get the initial values back. Okay, that means if I use a register as a counter, for example, x equals 0, for example, and every interrupt I'm gonna increment x. For example, you will find always x equals 0. Why? Because x equals 0. You increment in the subroutine, and then when you leave the subroutine, x is gonna get the initial value back, right? So if you want to memorize any value, you should not use a register because the register should get the initial values back. That's why here I use a memory location. Any question, guys? Okay. Now I'm gonna teach the same program but using C language. You will find it's just very easy. Number one, guys, look here. This is the interrupt subroutine is here. This is the main program is here. Okay. Let's look at the initialization. How can you initialize it? The way I'm gonna initialize it, guys, we have here one RTI initialization. We have a function here. This function is gonna set the timeout to 10 milliseconds. 10 milliseconds. Okay. You can, if you want to make it more than or if you want to change it, right, this function is not going to allow you to change the timeout. Okay, so if you want to change the timeout, you can actually use this one. You can say RT. So this function actually is going to do two things, by the way. So if you come back to here, and again, to learn better, you can open this function and you can see what is written there because it's written in assembly. What is actually inside this function is, let me clear this one first. So actually what is inside this function is these two things here. These two here. Okay. One to enable and the other one for this one. Okay. Again, you can, if you are okay with this function, you can use it. If you are not okay, so you can even change the function if you want, or you can write something like here, RTI CTL equal whatever. Okay. And again, in the past, in some ports we had a problem when we wrote something like that, it didn't work, and we found the best way if we can go inside this function and modify the number in assembly inside this function. This is one way to do it. Okay. But sometimes it works, or in some ports it works with us. Okay. Okay, so this is number one. That's it. So once you do this one, you already the RTI is gonna work. RTIs, you are gonna create periodic interrupts. And here, that's what I told you guys. All the time you have to use void. All the time you have to use the word interrupt. And now this is number 7. You remember in IRQ we used number 6. Yes, because every interrupt source should have a different number. Here we used number 7, and this is the name. Okay, that means. Guys, after I do this initialization, that means I am sure this subroutine, interrupt subroutine, should be called every 10.224 milliseconds. Okay, so every 10.224 milliseconds, this one is going to be called. Okay, and then similar to what we did before, guys, in order to make interrupt every 1 second. So 1 second means I should count for 97 interrupts, because 97 interrupts times 10.24 milliseconds, the result should equal around 1 second. So I have to count 97 interrupts. Is that okay? So that's what you see here, guys. Number one, I have a variable called text. Okay, this text should increment. So every interrupt you have to increment it by 1. Okay, and if it is not 97, I'm not going to execute this part, and then I'm going to clear. This is a function you have to use to clear the flag. This function is similar to this part here. Okay, to this one here. Okay, so you have to clear the flag bit. Someone can ask me before, should I put it in the beginning of or at the end? It doesn't matter. It doesn't matter where you put it, as long as it's in the subroutine should be okay. Okay, so here I'm gonna count for 97 interrupts. In the interrupt number 97, look what I'm gonna do, guys. Here, number one, I'm gonna toggle the LED. Also, tick equals 0. Why? Because I need to count for another 97. Very important thing. Very important thing can make problems to students. Listen to me. This variable text, where I have to define it. Listen to me. I know some of you are not very good in C language, and maybe just I want to make like remind you. So here, where I have to define this variable. Okay, if you define this variable text here inside the interrupt subroutine, remember this is gonna become like a local variable, which means every time you leave the subroutine, this variable is gone, right? So it's going to be local. Every time you leave, it's gone. For sure, I cannot put it here in the main program, because if you put it here in the main program, it's going to be local. Local means I have to use it inside the main program. Okay, so I cannot use here. Is that okay? where you have to put here, you have to put it in the outside here, because if you put it outside here, this is what we call global variable, global. Okay, so here global, so you can access this variable anywhere. Not only that, even when you leave the subroutine, this variable is not going to be deleted. This variable is not going to be deleted because it's not defined here inside here. Any question? Okay, let me tell you what I did so far, guys. Okay, because what I did so far, I explained two programs. Is that okay? I explained one program here for IRQ. Every time I press a button, you are going to shift one LED. Every time you press a button, you are going to trigger IRQ interrupts. And when you trigger IRQ interrupt, you shift LEDs. This is one program I taught. Second program I taught is how can you make a flashing LED similar to what we did in chapter 3, but in this time we did it using RTI. Is that okay? That's what I explained. Now I want to merge. I want to merge these two programs together. So now what I'm gonna explain now here is how I can use both RTI and IRQ. And this program is very important because actually the coming lab is just a simple modification to this program. So in the coming lab, I am telling you to first run this program and then do some modification on this program. Okay, so in this program, guys, I want to use IRQ and also I want to use RTI. Okay, you are going to use RTI to do what? I want to use RTI to do flashing LED. Okay, that's what you did right now. That is true. So here RTI is going to do flashing LED. Okay, so but now IRQ, I'm going to use IRQ in order to enable or disable flashing. Okay, what you mean? I mean, every time, for example, if flashing is working, I press a button, I trigger IRQ disable flashing. Is that okay? If flashing is off, when I press a button, I'm gonna trigger IRQ. IRQ is gonna enable flashing again. Okay, so I'm gonna use IRQ like on off. Okay, so flashing should be done by RTI. Okay, IRQ is used to turn the flashing on and off. How can you do that? Very easy. All what I have to do is every time I press a button, you actually trigger IRQ. IRQ is gonna do what? IRQ is gonna enable or disable RTI interrupts. You got what I'm saying? It's very simple. If RTI interrupts are enabled, what it means? It means we have flashing. If RTI is disabled, it means no flashing. This is the way I'm gonna do it. Okay. So now I'm gonna show guys. Now I'm gonna merge the two programs together. I explained it before. I'm gonna do little modification on the IRQ. Okay. So now let's see, guys. Here. So number one, here, this is for RTI. That's what I just explained right now. I have to add this part as well. This is for IRQ. Is that okay? So now I'm gonna have two interrupts, IRQ and RTI. Is that okay? This number one. Number two, here I have to write this one for this one is for IRQ. Okay, for configuration of IRQ. I have to write these two instructions for configuration for RTI. So I have to configure RTI and IRQ. Is that okay? And again, this is the main program is here because the main program, I'm not doing anything in the main program, just a very simple program. I'm going to keep looping here. And then when IRQ trigger interrupt, I'm going to go execute a subroutine and come back. When this is, for example, IRQ. When RTI trigger interrupt, I'm going to go execute a subroutine and come back. Is that okay? So here, I'm not going to be here all the time, okay? Because if there is interrupt, I'm going to go serve the interrupt, come back, go and come back, okay? Now, so now, what should I write here in RTI? This is identical to what I have just explained right now, okay? So I'm not going to teach it. This is exactly what I taught right now. So here, every interrupt you have to increment the count, okay? And if the count is not 8, just leave, do nothing. If it is 8, so now I have to clear the count so that I count for another 8, and then you have to toggle. This is what, so that means if RTI is enabled, that means you are going to have a flashing all the time. Okay, now what should I write in IRQ? What should I write in IRQ? As you see here, guys. Okay, in IRQ, okay, number 1, debouncing. This is a debouncing. Okay, and then look here, guys. Oh, in IRQ, I want to enable or disable RTI interrupts, right? How can you enable or disable RTI interrupts? Very easy, just one bit. I'm going to tell you where is this. Yeah, this bit. Just this bit. Okay. Here, all what I have to do, I'm going to flip this bit. So every time I press a button, I'm going to flip this bit. Because when you flip the bit, you are going to make RTI on, off, on, off. You got what I'm saying? So if it is on, you are going to make it off. If it is off, you are going to make it on, right? If you enable, you're going to make it disable. Disable, you're going to make it enable. That's exactly what I did here, as you see here. So every time I press a button, so if it is on, you are going to make it off. You press a button again. If RTI is off, you are going to make it on, right? This way. Okay, guys. So by this way, flashing is done by RTI. IRQ is going to enable or disable RTI. And if RTI is disabled, no flashing, because flashing is coming from RTI. Okay. Any question? Okay. Now I'm going to teach also the same program in C language. So here, this part here, and another one here. This is for IRQ and this is for RTI. This is similar to what I did before text. Similar, no different. Remember, you have to use number 7 for RTI. You have to use number 6 for IRQ, okay? And now, look here, guys. The way I did it here in C language is, I created a variable called status. I created a variable called status. This variable should have one of two values, either 0 or 1. 0, for example, means on, 1 means off. This is for RTI. So what I'm doing is that if RTI is on, I'm gonna make it off. If it is off, I'm gonna make it on. That's what I did here. Look here, guys. So for sure you have to define status here, okay? And then as you see, if status equals 0, okay, that means the system. If the system is off, so here I'm gonna make a status is 1, and then RTI enabled, okay? And then else, if so, that means, so if status is 0, I'm gonna come to here. If status is 1, I'm gonna come to here. Is that okay? If the status is 0, I'm gonna make it 1 and enable. If it is 1, I'm gonna make it 0 and disable. You know what this means, guys? That means here and here. So here, every time you press a button, one time I'm here, next time I'm here. Next time I'm here, next time I'm here. You got what I'm saying? So one time here, one time here. So every time you trigger the interrupt here, one time is here, one time is here. Okay? Because status, if it is 0, I'm gonna make it 1. If it is 1, I'm gonna make it 0. Okay? So that if it is 0, I'm gonna come to here. If it is 1, I'm gonna come to here. So if it is 1, I'm gonna make it 0 so that next time I come to here. If it is 0, I'm gonna make it 1 so that next time I'm gonna come to here. So one time I'm gonna enable, one time I'm gonna disable. So we have two functions here to disable or enable RTI interrupts. Okay, I think it's okay. You can try to do something like that in C. You can try it. I'm not sure if it's gonna work or not, but it should work. Okay, but here I did RTI enable or disable. Okay, so here in the main program, it's here I have to write this one. I have to write this one for configuration. Okay, guys. Any question, guys? Coming lab, okay, we still have 1 minute. I can, so by the way, in this chapter, I finished IRQ and RTI interrupts, okay? All what I'm gonna do is the rest of this chapter, I'm gonna give you different programs, different ideas how you can use RTI and IRQ, that's it, okay? So for now, what I wanna say is, in the coming lab, how the coming lab is a little bit different from what I taught here. In the coming lab, you are going to do little modification on this one here, okay? What I'm doing here is that IRQ, yes, IRQ. IRQ should enable or disable RTI interrupts, okay? In the coming lab, I'm asking you, okay, IRQ, when you press IRQ, okay, you actually, we have 4 tasks. We have task 1, and we have task 2, we have task 3, and we have task 4, okay? In task 1, I want to make a flashing every 1 second. As far as I remember, anyway, I'm just explaining the main idea, okay? In task 2, I think it was half a second. In task 3, so it should be 2 seconds. And task 4, no flashing. Okay, so it's a simple modification to this program, guys. All what you have to do, you have to make a variable called task. This number 1. Number 2, every time IRQ is interrupted, you have to increment the task. So if you are in task, if task, so task should equal task plus 1. But be careful. If task equal 5, so you have to bring, because after 4, it should come to 1 again. Okay, so if task equal 5, then should task equal 1. Okay, so number 1, I should have 4 tasks. Is that, guys? So every time I press a button, okay, I'm gonna move from one task to another. Okay, how I can do that? I'm gonna create a variable called task. Is that okay? This variable should have value 1. Okay, when IRQ is interrupted, I'm gonna increment it to 2. Or increment to 3, increment to 4. Okay, well, after 4, I have to bring back to 1. Okay, this is the first part. Second part, so IRQ is used to move from one task to another. That's very simple. Okay, now how I can make this part 1 second, half a second, 2 seconds, how I can make this part here, okay, or no flashing at all. Very easy. If it is task 4, I can simply disable RTI interrupts so that no flashing. If any other task, you have to make sure you have to enable RTI. Is that okay? So if it is task 1, you have to make sure RTI is enabled. If it is task 2, you have to make sure RTI is enabled. Task 3, you have to make sure RTI is enabled. Okay. If it is task 3, you have to make sure to disable RTI so that no flashing. This number 1. Number 2, in RTI, for example, in RTI, remember I'm gonna compare to 8, or I can compare to 16, or I can compare to number 4 for interrupts. 8, if you just 1 second, okay, 1 minute, okay. So 8, if it is actually 1 second, in case of 16 should be 2 seconds. 4 interrupts in case of half second, okay. So all what you have to do based on the value of the test. So if it is task 1, so here I have to compare to 8. If it is task 2, I have to compare to 4. This is one way to do it. If you can have another way to do it. I just want to go to show you where we compare here. Yeah, here, guys. When you compare to 8, okay, let me go to the main pro. Yeah, here, as I taught here, guys. Okay, as I taught here, we have a counter. I'm gonna increment the counter. If it is 8, okay, so every 8, I'm gonna flip. So if it is 8, I'm gonna come to here. Every 8. If it is less than 8, I'm gonna come to here. Okay. If I change number 16 or I change this number to 4, by this way you can speed up flashing or you can slow flashing. Okay. So every 16 interrupts or 4 interrupts. Okay. Any question, guys? So the coming lab is gonna be very easy, very easy. So on Wednesday, for the final exam, guys, we're gonna have up to chapter 4 in the final exam. Okay. I finished most of chapter 4. All what is left in chapter 4, just some programs, just to practice on how can you use IRQ and RTI, and I should finish them on Wednesday. Okay. Also, in Wednesday, also I may give a lecture during the lab. So we're gonna have 2 lectures, one in the lab, one in the regular lecture. In the lab, I don't think it's gonna be like I'm gonna make like a quickly explain what is chapter 5. I may record some videos to watch them later, but it's not gonna be in the final exam. So don't worry about that. So the final exam should cover chapter from 1 to 4. Okay. Any question, guys?
I have a quick question, Dr. Mahmood.
Yeah, sure. Go ahead.
Will the final exam be the scheduled time? I think it's Monday at 1.
I need to check online. So I'm not the one who decides the time of the final exam. So I'm gonna check. There is a schedule online, right? So I'm gonna check online. I'm gonna email everybody. Okay.
It's Monday.
Monday, what time?
1 to 3.
Okay. So I'm gonna follow what is written online. Okay, guys. Any other questions?
I have a question actually.
Yeah, sure. Go ahead.
Is the final going to be like the test we just took?
It's going to be something like that. Yes.
Okay.
But here the test, I try to be easy. I give you the choice to choose between C and assembly, but the final, I'm gonna give you two questions. It's gonna be similar, like as application, similar to this one, yes. So, but I'm gonna one of them is gonna be in C, the other one in assembly. You know what I'm saying? So you're not gonna have a choice. You should learn the two languages, okay? So one question is gonna be in C, the other one is gonna be in assembly, okay?
Right, right.
Any other question, guys? Okay, thanks. So see you on Wednesday.